All right, so we are recording for those of you who are watching this later. And what I'm going to show you guys is where everything will be. So right now we're in Unit 3, and I'm trying to post everything new in the assignments tab. That way I'm not putting anything in the course content other than the links that were already there in terms of the textbook screenshots and stuff there. So what I have right now in each of the 4 sections, you should have 4 Desmos reflections that you've either completed or hopefully are close to completing. In terms of due dates for those, if anyone who's watching this later or any of you guys watching have fallen behind, go ahead and get those in. Our Unit 3 test is not going to be due until after our break. We'll make sure we look at that calendar in just a second. But the Unit 3 prepare guide is right here, and it's a PDF guide. Hopefully it'll display for us well here so you guys can see that. Let me know in the chat box really quickly. We'll test that out again. Can you guys see that PDF that's being shared, or do I need to open up a different window? Okay, good. You guys can see it. Perfect. All right, so let's just go ahead and go through these topics. I'm going to talk through them, and then as we were saying with the Blackboard, if you have anything that's kind of lagging behind, we'll try to sync kind of any final due dates to when test 3 is going to close for that Unit 3. So the test I will open later this afternoon once these videos go up, probably by 5 p.m. that'll be posted. And then as far as completing it, you may have seen on the announcement this morning that we won't have a Zoom class on Wednesday. However, I do have office hours on Wednesday, and if you have any questions, you're still welcome to send me an email. I can record some quick videos, all of that kind of stuff, still in effect. Then next week, I do not see you guys the 13th or the 15th. So you'll notice that everything on WebAssign is due the 19th, that Sunday night before the 20th, that Monday morning. And so the test will close on the 19th. The WebAssign will close on the 19th. And if you have any Desmos activities that you need to kind of squeeze in, continue working on the reflections, get those in by the 19th. So don't worry, no deductions if you've missed anything, especially with all the craziness. So let's go ahead and go over our guidelines. We've got our 4 sections. You can use Desmos like always. And on this particular one, there's not a part 1 and part 2. Your test will be entirely on WebAssign, so you'll be able to use Desmos for the whole thing, just to kind of streamline our process. You can also use a calculator. You're not allowed to use any other websites, and it will be a time test. So I think the time limit that will be on there will be 2 hours, kind of like we would be in class. And then I've mentioned the note card that you can use, note card, double-sided, any formulas, any examples that you want on there. So in terms of our concepts, the first bullet point on here is kind of our longest. It includes everything with vectors rather than splitting those up. So for this one, component form, meaning if you have a start and a stop where you're not starting at the origin, being able to translate that over and down to the origin and write the component form. The trig form of your vector, being able to find that angle, which the good thing is after we've done complex trig or polar form of trig and then polar form in 10.6, hopefully we feel more comfortable with the trig form of the vectors now. We'll practice a couple of those today too. Then calculating magnitude and direction. Sorry, family just turned the lights out on me. Rewriting the vectors as a linear combination. So for example, if we had component form for 3, being able to write that as 4 units to the right and 3 units up, like 4i and 3j. That's what we mean there. We'll do an example of that. And then being able to calculate a unit vector and perform vector operations. In terms of your reflections, the calculating the unit vector was one of the things asked about most. So that's one of the things we'll take a look at on our list here when we switch over some problems. In terms of our next section, complex units, points 2, 3, and 4 are your complex units or complex numbers in trig form. So we'll do a couple of examples switching back and forth between A plus BI form and the trig form. We'll practice calculating the modulus, or the absolute value. And then De Moivre's theorem, you'll have probably one of these. It's not a big portion, but I think it can be one of the trickiest parts. So you definitely want to stick an example and write what the theorem says on that note card, since you will see that. Then in terms of parametric in 10.6, keep in mind your test is all on WebAssign. So in terms of the types of questions you're going to see for the parametric, it's very similar to the ones you've seen in your homework with the multiple choice, meaning I will give you the parametric equation for graphing and showing the orientation, and you'll select the correct graph with the correct orientation. So keep in mind, you can use Desmos. You can also kind of graph these paper and pencil using your points to show your orientation. There are some things in 10.6, if you read the textbook, that we did not specifically cover. Things like eliminating the parameter and some of the more complicated curves we did not do. So you won't see that represented either. And then in terms of connections between 10.6 and going to 10.7, the unit circle says graphing a circle, but in number 6, knowing the different parametric, polar, and rectangular forms of graphing a circle, I think if you can do the unit circle, you can change the radius. So what we mean by that is x squared plus y squared equals 1 is rectangular form. R equals 1 is polar form. And if we said cosine theta, sine theta, that's going to be parametric form. So we want to make sure that we can think about how our unit circle connects. Now, in terms of applications, we had a few Ferris wheel type problems, but not a lot of other types of applications here. Then, last point, in number 7, we want to be able to plot points in a polar coordinate system. Keep in mind, this is the place where Desmos can fail us a little bit, because Desmos doesn't understand when we're telling it a point. It's still thinking rectangular coordinates. It will understand how to create the graph of a unit circle if we're in polar form and we tell it r equals 1, but it won't necessarily plot our points like we're expecting. So keep in mind, kind of for these things, you would have matching. Like if I give you a polar point, be able to match up where that is on the grid, similar to the Desmos, similar to the WebAssign. And then if we have other points, be able to kind of write an equivalent point using coterminal angles or a negative radius. All right, so where we're going to go from here is I'm going to switch over to the iPad so I can write, and I'm going to pick some of these questions to look at, kind of go through the frequently asked ones that were sent, and then you guys are welcome to, in the chat box, if you have something you specifically want to go over, whether it's a WebAssign question, like for example, 10.6 number 1, something like that, or if there's a topic you want to talk about more, feel free to drop that in the box, and then I will see that. All right, so we'll switch over here, check the chat box. For some reason, it's not letting me see the bottom of the chat, so hopefully it'll tell me if things pop through here. It's just giving me a beep. All right, so let me go ahead and share the iPad. And all right, this is not us. Let me exit out of here. And just open up a blank page for us. So what I'm going to do is kind of look at our list of topics and talk through some of our points. So in number 1, let's say we have a vector. Let's do 2. Okay. So 2 vectors. If we are thinking about both of these vectors, you should be able to graph them. That shouldn't be a problem. I noticed someone popping something up in the chat box. Let me see if I can see that before we continue. Uh-oh, guys, I'm not sure what happened to my chat box. I'll try to go back to that in a second. Not sure. I don't think it popped through. If you sent something in the chat box, send it again. So in this first one, oh, hold on, guys. Okay, I've got a couple web assigned questions that pop through. Perfect. I will jot those down and make sure I add them to the list. All right, so we've got some web assigned for 6-6 that we'll get to. All right, so let's say we take a look at the two vectors that we have here. So both of these vectors are already in component form. So if we're looking at equivalent vectors, we could translate these over and think about a starting and a stopping. Most of the time though, given the starting and stopping, we would transfer to component form. Then we mentioned the linear combination of the other two vectors. So something like this. And then let's take a look at magnitude of each of these. So for magnitude, you guys did great with those on the activity and then also the web assign. Your magnitude is just think about the distance between the origin and the point that we have, or the origin and the terminal point. So square each, the x value and the y value in component form. And notice on vector v, we've got magnitude of 5 with this guy. And let's call our second one vector u. So for vector u, we square 1, we square 2. Keep in mind, we're still going to be the square root. And then let's see, this gives me square root of 5. So most of the time, if we're just kind of making up a vector, we're not going to have a nice even number magnitude. Let's go ahead and transfer to, instead of doing one in trig form, we're going to do trig form with complex in just a minute, so we'll kind of see how that's similar. Let's take a look at the unit vector part. So unit vectors always have a length of 1. And most of the time, the directions will say something like, write a unit vector that's in the same direction as unit v. So if we're looking at vector v, we really don't need like the angle necessarily. We just need to know kind of the slope. If you think about the slope going over 4 and up 3, if you can maintain that ratio, you're going to be good to go. So in order to make it length 1, we have to scale it down. So the easiest way to scale it down is to look at your magnitude and divide each component by the magnitude. So for vector v, this means a unit vector in the direction of v. You can just go through and divide. So what that's doing is condensing, and in this particular case, it's kind of easy to see and pretty clean. Now, in the case of our other example, where we have -1, 2, this one would require that we go ahead and do a messy denominator here. So on a test, WebAssign may tell you to rationalize the denominator. I'll try to make some notes, but keep in mind, you'll be able to go in there and see your answer once the test closes, and I'll be able to go in there and review those too. So if you enter something like this and it's wanting the rationalizing, I can always go in and give you override credit. All right, so any questions on our unit vectors? So one more note here. As long as you are already using the 3 and the 4, or the -1 and the 2, dividing preserves that orientation and then just changes that length. All right, so let me take a look back at our list here. And other things we could do that we might see on the test would be to add these two vectors. So if we wanted to add u and v, we would add our x components or our horizontal components, add our vertical components, and keep in mind u plus v would give me 3, 5 in component form. And then if we wanted to multiply and scale either vector up, and we want to think about a scalar multiplication, we could apply our scalar to each number. For example, something that has the length 2 units long in the direction of v, you might have something where you just scale up by 2 your unit vector that we already produced. So you can almost think about it like distributing in this particular form. All right, so that was the main question that we had for topic 1. Let's take a look at topic 2. So trig form as well as a plus bi form of complex numbers. So for this one, I want to make sure I direct you guys back to the card sort. When I logged on to Blackboard this morning, for some reason, my card sort picture wasn't viewable anymore, so I'll try to upload that again. But I'm going to take us back into the Desmos really quickly. And switch us over to the Desmos screen here. So if you guys are able to get into your trig form of a complex number, go ahead and do that. And I'm going to share the teacher view with you guys. And what I want you to note, first of all, is just for the card sort, I'm not going to make them anonymous because I want you guys to be able to see your card sorts. Look, I have my card sort, so I'll show you the key. I went in there as a student and did that to do the key part because these are a little bit tricky. So I think the card sort slide was the one that was the most tricky. And even if you just have one card wrong in your card sort, you may be displayed as all red. So what I'm going to do is switch it over to my view as the student view. And then show you kind of the pairings that you're going to see. This one was really interesting in that some of the pairings, for example, we could have a plus bi form, like 1 plus I, and you could have a trig form and a graph that were matched. Other ones, for example, this -2 times the quantity 1 plus I squared of 3, only matched with a trig form and no graph. You had some, like this particular card, that matched with a plus bi form and the graph, but no trig form. Okay, so what we want to do is pick at least one of these to go over. I have an example, a couple different examples that we can take a look at. But before I do that, anyone have one card in terms of a plus bi form or trig form that you would like to start with and convert to the other form? Otherwise, I will pick one. Okay, I don't see anything popping through. So let's go ahead and I will see if I can paste in another picture, but I will also come back to this if we need to. I'm going to stop this share and go ahead and share my iPad again. And what we want to do is maybe something like, let's go both directions. Let's say we have a plus bi to trig form. Let's do that first. So in this particular case, let's say we have 2 minus 2i. When I'm working through these, whether it's the card sort or I'm doing a conversion, I always think about graphing if I can, whether I'm in trig form or the a plus bi form. So I would say, okay, I'm going over 2 in the real axis. And then keep in mind, your imaginary axis is what we would normally call our y-axis. So you're really going down 2 here. So in terms of my trig form, I always think about visualizing my modulus, and I always think about the triangle that I'm creating. So if you think about triangle, you have a reference angle. And if you can picture that reference angle, then you can get the angle and the modulus and write the trig form easily. So in this particular case, we can see the symmetry and we might be able to guess at 45 degrees. But if not, think about we've got 2 and 2. And if we think about the arctangent, it's always going to be the arctangent in this case. And I'm going to go ahead and I'm going to make this just notation-wise my reference angle. So I'm going to add a prime on there so I don't have to think about negative at this moment. I can just think about if it's a positive, for example, pi over 4, pi over 6, or pi over 3. So the arctangent of our reference angle is going to be 2 over 2. Excuse me. Sorry, guys, I messed that up here. Let me just say that again. I should not have written that. The tangent is going to be 2 over 2, which means the angle is the arctangent of 2 over 2, or in this case, we could just write 1. Sorry, guys. So I should have written theta equals the arctangent of 1 there. So if you drop this into Desmos, Desmos will tell you that this angle, if you're in degree mode, is going to be 45 degrees. Or radian mode pi over 4. I would actually say that if you were trying to do these conversions, put yourself in degree mode because Desmos is going to give you a decimal approximation and not the actual pi over 4. Also, if you recognize that it should be at 45 degrees, great. You don't necessarily have to go through the arctangent. But let's go ahead and think about our modulus. For our modulus or our radius, think about our radius is going to be the square root of our 2 squared plus 2 squared. This is going to be square root of 8 or 2 square root of 2. So when we get this one, we want to make sure that when we're putting it together, if we found our reference angle, that we put it back and make sure we think about either making that negative, or we can think about making a coterminal angle that's between 0 and pi over 2. So let's go ahead and jot this up here. So our radius is 2 square root of 2. And then we're going to say cosine, I'm going to use degrees here, plus I sine 45 degrees. That is it. Or we could substitute that pi over 4. And guys, I'm going to plug my computer up so I don't lose you guys like I did last week. I feel like my light is a little bit hard to see this morning. So, you guys can see okay. So that is it, right? So in this case, the trig form definitely looks more complicated than our a plus bi form. Now, one of the questions specifically that was sent was about going backwards in terms of kind of special angles. So I think the question was something like this. It was going from trig to a plus bi. So if you had something like 3 times cosine of 155 degrees plus I sine of 155 degrees. 155 degrees is not one of our special angles that we know. So let me contrast this one entirely with something like this. Let's say I have cosine of pi over 2 plus I sine of pi over 2. I think number 2 is easier, right? Because number 2, we can easily go ahead and evaluate cosine of pi over 2 and sine of pi over 2. So cosine of pi over 2 gives me 0. And then sine of pi over 2 gives me 1. So notice this is giving me 3 times 0 plus 3i, or just 3i. So technically this is a plus bi form. You really could leave off that 0, 0 plus 3i. It's not really necessary. But it hinged upon our ability to evaluate this cosine of pi over 2 and sine of pi over 2 easily and have an easy value to plug in. So when I see this cosine of 155 and sine of 155, we don't have these numbers memorized, and I don't expect you to. You would just pop this into Desmos and get the value. You know the value of cosine always has to be between -1 and 1, and your sine always has to be between -1 and 1. So you would just use Desmos, whatever it is, and plug in. So let's go ahead and leave this one there. So use Desmos to get those parts, and then you would distribute here. This is actually going to get a little bit messy, and you're likely going to see ones more like number 2 on your test. So let me know if that makes sense on number 1. And let's go ahead and take a look at, go back over, take a look at our prepare guide. Let's see. I think the next question that I had was out of 6.6. So what I'm going to do is open up my WebAssign 6.6 and take a look at those ones for us. Sorry guys, I'll switch over to WebAssign if I need to. If otherwise, I'll just run it for you guys. So I'm not switching too much. Okay, so I think actually number 12 and 13 were very similar to what we did. Let me just take a quick variation. Number 12 on this one is similar to that one that I just worked. Let's go ahead and finish this one up because this gets a little bit messy. So if you are actually finding, in this case, actually this one doesn't get messy. This one I was thinking 153 for a second, but this one, let's go ahead and work it out in terms of our cosine and sine here. So for this one, I definitely graph it. See, I have a radius of 3. So I can think about that being unit circle, but well, not unit circle, radius 3, and then I'm rotating 135 degrees. So think about if you rotated 90 degrees, you have 45 more to go. So you're going to be somewhere out here. And the reference angle that we have to think about in this case is 45 degrees. And the actual angle that we're thinking about is 135 degrees. So in this particular case, we know our